think we should get going. So good evening, everyone. My name's Matt Glenn with the Gundalow Company, taking hosting duties from Rich today. But I want to welcome you to our next installment of Gundalow Gatherings. So I think it's been a really great series. I know quite a few of you have tuned in for a number of these, and it's good to see so many familiar faces. We may do one more Gundalow gathering next week or the week after, or this may be the final one. We're not quite sure. But just for a quick update from Gundalow Company, we've been really hoping that we could offer some sort of summer camp this year. With recent updates from the governor's office, we are now hoping to, or planning to run a short summer camp, a day camp with half days offered. So that's exciting that we can do that with a lot of new safety measures in place. As far as sailing, we're trying to work towards a July 1st start date. So in the coming week and a half, the crew will start getting back aboard and training and getting the boat ready. So that's what we're working towards if everything still looks good at that point. We hope to get you out in July and August. As far as housekeeping items, I'll keep the mics muted until the question and answer at the end. If you have questions, feel free to type them into the chat box. And you can just type, I have a question, that would be enough. And I can unmute you towards the end and you can ask it in person if you like. We are recording this. We hope to put it online later, just for your information. If you have any technical issues, you can email info@gundalow.org and Andy there will get that. Or you can even call our office number and somebody will be able to answer the phone remotely. All right, so before I introduce the speaker, I'll just mention this is World Ocean Week, so happy World Ocean Week, everybody. We are partnering with a number of great local organizations, Seco Science Center, Blue Ocean Society, from the Bow Seat, and the League of Conservation Voters. So if you look on our website, you'll see all week there have been a number of events going on. And there's still time, it's not quite over. I think tomorrow I saw something about a visit with a baby octopus on the schedule, and a 5K on Saturday that you can run wherever you choose. There will not be a River Fest on Saturday, unfortunately, but still some great events there. So turning to the presenter for this evening, our focus is usually very regional, all about our watershed, but I'm very happy to be able to introduce a friend of mine, a former shipmate from Sea Education Association. So Jeffrey Schell is a professor of oceanography with Sea Education Association, a renowned study abroad organization that prepares college students to become the next generation of marine environmental leaders. SEA offers academic programs in marine environmental studies. Since 1994, Jeff has guided students through the challenges of oceanographic field research toward the thrill of discovery while sailing on board the tall ships Westward, Corwith Kramer, and Robert C. Siemens. To this day, Jeff has taught 40 sea semester programs, logged over 1,600 days at sea, and sailed over 75,000 nautical miles. So I worked that out, I think, to 3.5 trips around the equator, although I know that's not exactly what you did. But I'm quite jealous of those sea miles. Jeff's research interests include the biogeography of zooplankton communities, ecology of the Sargasso Sea, and response of coral reef ecosystems to climate change and pollution. And I think the last trip I did with Jeff a few years back included the Sargasso Sea and visit to Jamaica maybe, and Christmas at sea. So very happy to have Jeff here with us tonight, and I'll turn it over to him.
Great, thank you, Matt. And yeah, thanks to everybody that has shown up tonight. Yeah, I really appreciate the invitation from Matt from Gundalow Company, and I'm excited to spend the evening with you here in celebration of World Ocean Week. So I'm going to share my screen here in a little bit and jump to the slides. But I just wanted to thank Matt, thank Gundalow Company, and thank all of you before I start looking at all the slides. All right, so sharing my screen, making sure you can hear the sounds. World Ocean Day, that's what we're celebrating. At least you're celebrating for the week, and I think officially is next week, Monday. But I'm really excited. And I was checking out the World Ocean Day website, and this was a great logo that they had on their front page. And I'm gonna try to play off of this theme, love our beautiful ocean, as I take you beyond the waters of New England, out into the rest of the world's oceans, and share some stories with you. As Matt mentioned, I'm a chief scientist with Sea Education Association. So most of my stories are going to be talking about the science that we do, but along the way, you'll see the ship and some of the wonderful places that we visit. I have to say thanks to Matt, in case some of you were not familiar with Sea Education Association and the Sea Semester programs that we offered. I was going to give you a brief introduction to our program. But really, just to say that we take not only college students, but we also take high school students and gap year students out to sea. And we share the ocean experience, the sailing experience, the science, as well as the history and the culture of the places that we visit. Our signature program is Sea Semester. And these are undergraduate programs that we offer throughout the year across the world's oceans. Coming up this fall, we'll be offering some of our first gap year program offerings for students. And then over the summer, we offer experiences on the ship as well as at our campus in Woods Hole for high school students. If you're not familiar with Woods Hole, it's home to 6 research institutions close to Providence, Boston, New Bedford. Anytime students come to Woods Hole during the shore component before they go to sea, we share all of these regional research institutions and the work that they're doing there with those students. But this is what people sign up for, not necessarily to come to Woods Hole during the shore component, but to go sailing with us on the Robert C. Siemens and the Corwith Kramer, and our original vessel, the Westward, though no longer in operation with our program. So it's time spent on these ships where students become members of the crew, they become working members in the lab, but they're also helping in the engine room and the galley. They're full participants in the operation of these vessels as we travel from one destination to the next, learning about the people and the cultures that we're visiting, but also conducting real oceanographic research. And it's that scientific research that I'm going to focus on as we span between the Pacific Ocean, the Caribbean Sea, the Atlantic, as well as the Mediterranean. So I'm going to take you on 4 different cruise tracks, and we'll actually talk about some data, observations from 5 different Sea Semester experiences. As you can see, we'll look at two different cruises, same cruise track, different years in the story that tells us. To start us off with these science stories and our adventures, we're going to go to the Caribbean and one of my favorite places, Silver Bank. Silver Bank itself is a sister sanctuary for humpback whales. During the summertime, and they're making these migrations and probably already established themselves up in Stellwagen Bank for the summer. Right there north of Cape Cod, south of where most of you are, humpback whales congregate in the summertime. It's a great place to feed in the summertime. But in the wintertime, when it's not so, so warm, most of these whales will migrate down to the Dominican Republic and a shallow bank just north there, Silver Bank and Navidad Bank. Samana Bay is also an area that they occupy during the winter season. And not as much food down in Silver Bank and Navidad Bank, Samana Bay area, but it's warmer water is a great place for mating and calving of young humpbacks. So during some of our Sea Semester programs that sail in those waters, we study the ocean soundscape. Not only are we listening for whales, but we're really listening to any sounds that are coming from the ocean. Hopefully most of those sounds are natural sounds. So the ocean soundscape can come from anything from the whales themselves to the crashing of the waves, rain falling on the sea surface, calving of icebergs if you're in those latitudes. And as we'll hear in some videos later on, small snapping shrimp, particularly in the tropics. Those are all natural sounds, and we are interested in studying the natural sounds in the waters around Samana Bay, Silver Bank, as well as listening to humpback whales. But we're also going to be listening to acoustic litter, man-made sounds that are also, unfortunately, more and more crowding out the natural sounds in the ocean environment, to see if that had an influence on their behavior, the behavior of humpback whales. So we were partnering with folks from NOAA to conduct these studies. And when we were anchored on Silver Bank, we indeed were seeing a lot of whales, and we were hearing even more of them. So there's one of our sea semester students, and then next to her in blue, Dr. Heather Heenahan from NOAA. So she brought her hydrophone along. We had that hydrophone plugged into a nice recorder. We were able to record hours and hours of humpback songs, as well as a lot of ship traffic. Because of these whales, this is a popular spot, particularly in the summer, for whale watching and observing. So that boat traffic introduces a lot of noise into the environment. And it's a shallow bank, so it's also a very heavily area that's used for fishermen. So we were picking up all of that anthropogenic or human noise as well. So we're seeing scenes here of putting the hydrophone over, keeping track of whale observations and seeing if whale behavior changed when there was a lot more boat traffic around or not. So collecting data along the way. And when we would plug those recordings back into the computer, upload that data, we had software that allowed us to turn that sound into a visual representation of that sound. So what we're seeing there in the upper right-hand panel is what's called a spectrogram. We're seeing different sound frequencies showing up on that graph. And then there in the bottom, we're seeing that same spectrograph in a black and gray scale. And now an opportunity to listen to whales. Now that was just like a cacophony of whales. If you've had an opportunity to hear humpback whales before, you might have, been familiar with some of those sounds, but not to see them layered on top of each other. So hard to say exactly how many whales were in that recording, but it wasn't uncommon for us at any one point in time to see 4 or 5 whales actively breaching or blowing at the sea surface. Now, most of those whales aren't the ones that are actually singing. So hard to know exactly how many whales were part of that. But if, when things quieted down a little bit, what you can do is really begin then decoding and mapping the song for that year. Every year, humpback whales develop a new song that males use to attract mates. And we can see in these early phases when we are visiting Silver Bank, how that song develops and shifts and changes over time. And sometimes notes from previous years are used again, but then a new sort of accumulation or a grouping of notes comes together to create a new song. So for the past 4 or 5 years, sea semester students have been able to partner with NOAA to keep track of the changing whale songs that you find in Silver Bank. And those are the same songs that you would hear again then on Stellwagen Bank in the summertime. So this is an opportunity to take a look at some of the whale activity that we had at the sea surface.
Oh my God. Yeah, where's Cooper? This is not a normal day in the office, Cooper. I don't know where he is. Oh my gosh. Rainbow blow. Rainbow blow. It was a rainbow.
Now, I don't know if everybody saw that. We're going to go back and play that video again. But right around here on your screen, that second blow turned into a rainbow. So it's worth checking out.
Oh.
second flow.
Yeah, where's Cooper? This is not a normal day in the office, Cooper. I don't know where he is. Oh my gosh. Rainbow blow. Rainbow blow. It was a rainbow. It was a rainbow. Hashtag rainbow. Hashtag rainbow. Hashtag real pizza.
We'll stick around for a little bit longer here.
Oh my gosh, baby.
So, singing whales in rainbows there on Silver Bank. Just one of the many experiences that sea semester students are fortunate to have, and that I have been very fortunate to have over the many years that I've been working with sea semester. So, a reason to celebrate. Well, celebrating rainbows, very different. This was a cruise back in 2016, cruise S267. So this would have been on our ship called the Robert C. Siemens, the 267th cruise that we had done. And we were studying coral reefs in crisis. This was the cruise track. This was going to be a cruise from Tahiti all the way to Hawaii, with stops at 3 very unique environments in the Pacific Ocean called coral atolls. So these are old volcanic islands that through time have subsided and eroded away. Because of the latitudes in which you found these volcanic islands, coral reefs were able to form around the rings of those volcanoes. And then as that volcano eroded and sank away, the coral reef, the ring of it, remains. So we're going to be visiting 3 different coral reef environments at a time where things were changing. This was back in 2015, and maybe if you were paying attention to some of the headlines that were coming out of the West Coast and the Pacific Coast areas, you may have heard about one of the largest El Nino events that had ever occurred, had ever been recorded. What we're seeing here in the animation, we're comparing what had previously been the largest El Nino back in 1997, 1998. And we're seeing these warm temperatures indicated by the white and reds and yellows right around the equator. When an El Nino event occurs, we see these warm temperatures shifting from the western side of the basin over to the eastern side of the basin. And then that pool of warm water builds and builds and expands. Well, that warm pool of water was beginning to build and build in 2015, the year before we were going to sail from Tahiti to Hawaii to examine coral reefs. At the time, NASA scientists were beginning to refer to this as a Godzilla El Nino because it seemed like it was going to be the largest ever recorded. And if you take a look at those warm temperatures there in the eastern Pacific Ocean, it is pretty reminiscent of the laser beams being blown out of the mouth of Godzilla. So I think I understand like where the name comes from. And it's these warm temperatures that you see here in the Central Pacific, Eastern Pacific Ocean associated with El Nino events. These warm temperatures can lead to coral bleaching. And we can see those bleached corals here in the image off to the right. So for a whole year, this El Nino was raging across the Central Pacific, right through the area in which we were going to be sailing from Tahiti to Hawaii. So we had a hypothesis that we were going to see a lot of bleaching in the area. So we're getting ourselves ready for a cruise, right? This is a long cruise. All of those port stops, there was no place we were going to reprovision along the way. So there was a huge order of fruits and vegetables before we left. There's also a whole truckload of big cans of food that went into the hold as well. We're getting ready for a long voyage. And of course, we have to get the students ready for a long voyage. As I've mentioned before, that they are part of the crew. So there's a lot of safety training that is involved before students head out to sea on our ships. And here's our first day, sailing to the islands. Students at the helm the first day. Students are working the lines, working the sails as we are making our way to explore these different coral reefs. And of course, above the sea surface, there is plenty to see, some wonderful sights. But these students were most excited to see what was going to be going on beneath the sea surface once we started exploring these different islands. So once we got to these islands, this was our approach. We were going to be laying transects out across the reef, using quadrats and underwater cameras. We were going to be taking photographs as well as writing down on dive slates, different colors of, or different amounts of coral cover, whether or not they're bleached, living, diseased in some way. We're also keeping track of any fish and invertebrates that we see along that transect as well in a number of different ways. Belt transects, roving surveys, stationary point counts. These are all standard fish counting techniques that you can use on reef environments. But because we were sampling in these Pacific reefs, many of them uninhabited, we also had to prepare ourselves and train what to do if sharks swam by. So we spent a fair bit of time preparing our students to be in the water with sharks. This should be something that we are excited about, but we're also cautious about. I'm going to show a video here in a little bit. We're going to explore Rangiroa, Carolina Island, as well as Christmas Island, and see what we discovered in response to this Godzilla El Nino event. So you see them equipped with dive slates and cameras in the water, ready to write down the observations. Swimming with their quadrat. There's some in the fish survey. Here's our first island, Rangiroa. I have just a short video there of Rangiroa. We're going to pause right there. And you can see, right, that was we expected this. This El Nino had been raging for a year. We knew these warm temperatures were probably going to lead to bleaching, and here we were documenting it. Normally, all of these features here, all of this coral would have some kind of yellowish, brownish, greenish color associated with it. That's when the coral is live and full of their symbiotic symbodinium, a type of dinoflagellate that is doing the photosynthesis and providing a food resource for the corals. Now, because of that bright color, it may be that these corals are still alive. They have been bleached. They've released their symbodinium dinoflagellates because they're in stressed conditions. If there's still a food source, right, coral is an animal, it's a colonial animal feeding on plankton as well as getting the energy from their symbiotic dinoflagellates. It may be that these corals can survive if conditions improve. But we'll see if that is the case. So that is Rangiroa. And we'll now go to our next island. So a little bit more color in the corals here. That's sort of a good sign. But as we take a closer look, you'll see that there's like a red hue on some of the corals. You still see a lot of bleaching. But that red hue is actually coral that has been bleached and dyed. Now there's a small bit of filamentous red algae growing on that coral. We're just showing some of the student work, laying down that quadrat. Next student dives down and is going to take a photo of that. And from those photos, we can go back and then do a pretty thorough analysis then of coral cover. How much of that quadrat has bleached coral, how much of it has diseased coral, how much of it is living coral. But just in case, That image quality isn't come back high enough resolution for us. We still have somebody with the dive slate recording observations as well. So we just have a backup just in case. And while some students are laying out these quadrats, other students are looking at the fish counts. And just kind of pay attention here in Carolina Island. You see a lot of sharks. And here is our person designated on shark lookout. You may have noticed that they had a long PVC pole that just in case those sharks came too close, we could keep them out of the way. But for most cases, the sharks kept their distance. We kept our distance. And here we are at our third island, Christmas Island. Here's a close look along our transects, our quadrats. And I'm going to pause right there for a moment. And what we're seeing here is coral that has long ago bleached. Perhaps at some point had some small algae growth on it, but what's growing on it now, that pinkish color, reddish color, is called a crustose coralline algae. It's an encrusting type of red algae, and that's actually a good sign. This is a type of algae where if corals were to recruit to this area, corals could actually start growing on top of that red encrusting algae. So this is a reef that perhaps has a chance of recovery if the right conditions were to come along. So taking a look at our reef survey results across our 3 islands, we saw a tremendous amount of bleaching. And here's just looking at some of the numbers. Incredibly low percentages of live coral, high percentages of bleached coral or dead coral with algae or crustose algae growing on top. There we see in Christmas Island. So this is what we expected because of the El Nino event that was going on. But never an easy thing to see, one reef after another going through these dramatic changes. So I will admit, this was one of those cruises where you sort of end the cruise where, man, we learned a lot. We did some amazing things, but we were seeing reefs in decline. El Nino conditions don't last indefinitely. In 2016 and 2017, we were sailing in those waters just as that El Nino event was ending. So in 2018, cruise S280, when I returned to these reefs with a different group of students, the question was, were these reefs going to recover or not? So we had our fingers crossed, and let's go and take a look at what we found. It may look the same, but these are all different students, but we're using the exact same techniques. Dive slates and cameras, transects and quadrats. Everybody had to learn how to swim with sharks again. And pretty soon we're gonna now start taking a look at each of our 3 reefs. So here we go, Rangaroa. This is a technique that I didn't show earlier. As I mentioned, coral is a colonial organism that feeds on plankton. So we were here measuring the plankton on top of coral reefs to see if those food resources were sufficient enough to even allow bleached corals to still have an ample food source to survive those time periods when the waters are too warm for them. Now we're going to take a nice close look at the coral. We don't see nearly as much bleaching. That's all live coral that we're seeing in front of us right here. So this was a good sign. This is what we had hoped for, and this is what we found. So in this case, it was great to have our hypothesis supported by the observations. The coral reefs, when those warm temperatures from the El Nino abated, the corals were able to recover. And what we're seeing here, I didn't show a lot of pictures of fish in the earlier cruise because there weren't that many fish. And it wasn't until we returned 2 years later that we understood what the fish populations could look like when the reefs are healthy. So So the rest of this video is gonna focus on sort of two things to pay attention to. The fact that the color has returned to the corals have returned, but then the fish diversity that you see swimming around these reefs. The last time we were in Carolina Island, we saw those white patches and then a lot of coral covered with that red filamentous algae, and some of that coral has died. Some of that coral didn't return. So I can sort of see that here. There's some living coral here. But some of that coral that had that red filamentous algae growing on it never made it back. But we don't see any bleached coral, and we see a fair bit of live coral. And look at all of those fish. Small, right, young, juvenile fish. You were not seeing those numbers of fish 2 years ago. Still have our sharks. So everyone's always excited to see the sharks swim by. And then again, some more close-up views of the reef recovering, the communities of fish recovering in abundance. We'll take a closer look. We also saw an increase in the species diversity over this time period as well. Oh, and what you're hearing in the background, that chatter are right, much louder in this video than we heard it 2 years ago, snapping shrimp. So a healthy reef environment is a very loud environment. Tons and tons of snapping shrimp, defending their territories on the reef. So if you can remember the pictures from earlier, right, no bleached coral in these pictures here. So live coral returning, right? The whole reef isn't alive, right? Some of the corals didn't recover fully, but we don't have any active bleaching. As that El Nino condition abated, the water's cooled down, the corals have come back. But not all of the coral has returned, unfortunately. But there's a sign of hope and a great return of fish diversity as the coral reef recovered. What we're seeing here in these two different panels, where that white line is in the bars of data, those were the numbers of fish abundance and fish species richness in 2016. And then S280 levels, that's 2018. We can see that the fish abundance increased when those El Nino conditions abated. So this was a cruise that was, again, something to celebrate the success that indeed we had coral reefs recovering in 2018. All right, now we're going to jump over to the Mediterranean Sea and go hunting for meddies. So this was the cruise track, Barcelona, Mallorca, Cadiz, Madeira, and then eventually to Gran Canaria, Canary Islands. We are interested in a feature that forms in the Gulf of Cadiz. So this is an area where the Mediterranean Sea, the warmer, saltier water, as new water from the open Atlantic Ocean comes in at the sea surface, salty water from the Mediterranean exits. And we are collaborating with Dr. Federico Aina, he's Italian, but he's at a university in Portugal. And he's interested in studying these underwater eddies or Mediterranean eddies that form this salty, warm water that exits the Mediterranean Sea and forms these circulating features. Now, these are massive features, 600 meters thick, several kilometers wide, huge volumes of water. And this is important because you need that water to exchange. New water coming in at the surface, deeper waters exiting from the Mediterranean, and on the long-term scales, this mixes the Mediterranean. But what Dr. Federico is interested in is if the Mediterranean warms up too much, that deep water meddies, they won't form. And you won't get that amount of circulation of the Mediterranean Sea if those waters warm up too much. Now, you can't go sending out a whole fleet of ships looking for these meddies, And he had developed a way of identifying where these underwater features are by looking at subtle changes in what's going on at the sea surface by using remote sensing data. But he needed to ground truth that remote sensing data with actual measurements. So that's why he was on board the Corps with Kramer. We were going to go out hunting for one of these underwater meddies using the equipment we have on board the Kramer, and he was going to then ground truth that with data he was collecting from satellites. So as we were leaving Cadiz, heading offshore into the areas where these meddies were to be found, this is when a gale from the North Atlantic happened to be working its way to that exact site. We did have to alter our cruise track. We had to actually run away from that gale and return to Cadiz. But for a day, we sailed toward that gale because we wanted to see if we could find that meddy. So as that gale is approaching, we are conducting our science station. And gear went in the water. Gear came back out of the water. Captain Elliot Rappaport, some of you may know Captain Rappaport. He was like, all right, we are heading back to Cadiz before this gale catches us. Gear out of the water, starting to set sail, and realized the gale was upon us. And here is a water spout that is beginning to form. By the time it had fully formed, I had put my camera away. But here are the students hopping to and getting the work done necessary to turn the Kramer around and start heading back to Cadiz. And he is actually looking at that water spout right now forming right there. And at this point, we said we're not going to be able to sail fast enough, so we're striking sail, and we're going to motor the rest of the way back to Cadiz. And we made it back safe, of course, no problems, but a great sea story for all of those students. And more importantly, while we had put ourselves in that position to have to run away from a gale, is because we were hunting those meddies. And did we find one? Well, indeed we did. So here's our transect leaving the Straits of Gibraltar. And it was this station right here where we thought we were going to find ourselves a meddy. What we're seeing here is a cross section of these different CTD casts. So now we're looking at the sea surface, and we're looking at how temperature changes as you go deeper down in the water column. And this is what a single CTD station looks like. This is a profile of salinity as you go down from the surface deeper down into the water column. And it was this area here, these higher salinities at these deeper depths, that was the telltale sign that we had indeed found ourselves a meddy. So now Federico had his data. He was going to be able to then compare that to the satellite information that he had. Mission accomplished on this cruise. So did we find, we went hunting for a meddy, and indeed we found one. And now for our fourth and final cruise track, discovery in the Sargasso Sea. Now for some of you, if you're familiar with the Sargasso Sea, this might be an unusual location for the cruise track, sailing from the Canary Islands to the Caribbean. You might be thinking to yourself, that's not quite where the Sargasso Sea is it? Well, we'll get to that here in a little bit. But for those of you who aren't familiar with the Sargasso Sea or with sargassum, here's a picture. This is a clump of algae drifting around in the North Atlantic Ocean called sargassum. And this is our cruise track. It was going to be from Gran Canaria to St. Croix along the way. And typically, this would be a cruise track where you would not find sargassum. Historically, this was not a place where sargassum was to be found. But there was a reason we thought we might find it here. But before we get to that reason, first of all, a little bit more about sargassum. So a drifting little clump or ball of algae floating around, I think of it as a drifting oasis in the sea, because crawling and hiding all around that clump of algae is a whole community of organisms. Some of them found nowhere else on the planet, but living in these drifting oases. There are species of shrimps, crabs, fish, nudibranchs, polychaetes, snails, barnacles, anemones. All manner of creatures live in this little floating, drifting environment. So many people study sargassum because of its abundant and diverse community, this oasis in the sea. But the reason we were going to be studying sargassum on this particular cruise is because sargassum had been showing up in really unusual places. Beginning in 2011 and 12, huge amounts of sargassum started washing up on beaches in the Caribbean. And then as word began to get out, we were hearing that sargassum was washing up on beaches in South America, the western coast of Africa, all the way to the Mexican Caribbean coast, and then working its way into the Gulf of Mexico as well. 2013 was a quiet year for sargassum, but then in 2014-15, these events returned. They became referred to as sargassum inundation events. And this was leading to millions and millions of dollars of damage to these coastal communities. Loss of tourism, loss of local artisanal fishing industries in the area. People couldn't get their boats out of harbors under some circumstances. And it was devastating these coastal ecosystems. Coral reefs were being damaged by these large inundation events, as well as turtle nesting beaches were being damaged because of these events. So sargassum at sea, an incredible diverse community, but when sargassum is washing up on these beaches, that is a major ecological disaster. And the question that was coming out was, where is all this sargassum coming from? Sargassum hadn't been washing up on these beaches in any sort of, history that anyone could remember. So historically, where has sargassum been? The solid line and the dashed line are two different time periods in 1891 and 1923, the distribution of sargassum. In 1964, that hashed circle is where a review paper by Dooley in 1972 identified as the center of the Sargasso Sea. Now, many people were trying to point to the Sargasso Sea, of course. Where is sargassum coming from? Well, of course, the Sargasso Sea. But because of the ocean currents in the Sargasso Sea, that wouldn't necessarily be the place sargassum would come from if all of these islands in the Caribbean, African coast, South American coast were being inundated by sargassum. Ocean currents don't necessarily flow in that way. Working here in Woods Hole, I have access to incredible historical archive. And I was familiar with Matthew Fontaine Maury in his book, Physical Geography of the Sea, published in 1856. And in some of his old historical charts, he actually maps the Sargasso Sea in this area here, having this eastern component of sargassum. If anyone is familiar with the name Alexander von Humboldt, well, you can find his works also in the archive here in Woods Hole. And if you look at some of his writings and you map his distributions, this is where you find sargassum back in 1814. And you can see that there's this eastern component in the Sargasso Sea where he has found sargassum based upon ship's logs and journals. And of course, if we go to Christopher Columbus, he actually talks about sargassum a fair bit in his journals because he thought it was a sign of land. This is the first time somewhere approximately we believe Christopher Columbus was when he first mentioned sargassum in his logbooks. So historically, there's a suggestion that Sargasso Sea used to have or extend itself to these eastern sides of the Atlantic Basin. And from this location, you could see ocean currents here in these arrows. Ocean currents indeed could bring it from the eastern part of the Atlantic Ocean into the Caribbean region. So that was our hypothesis for this cruise on C256, that indeed just some long-term change in North Atlantic circulation was leading to an accumulation of sargassum on the eastern side of the Sargasso Sea. And we had the perfect cruise track to test this hypothesis, sailing from the Canary Islands to the Caribbean. And as we left the Canary Islands, we crossed each one of these boundaries. Everyone was excited when we were crossing the boundary into Matthew Fontaine Maury's Sargasso Sea, and we did not find any sargassum. That's all right. When we got to the area that Christopher Columbus first mentioned sargassum in his logbooks, we're sure to find sargassum there, right? Well, we didn't. And I thought, Humboldt he's actually I'm a big fan of his. So maybe he has it right. So as we crossed into his boundary of the Sargasso Sea, I thought for sure we'd see sargassum, but we didn't. So at this point, we had to stop looking for sargassum. We had to make our way to the Caribbean, and we weren't quite in the best latitudes to catch the trade winds. So we started heading south and had given up our search for sargassum. But on the 1st of December, 2014, it was the start of a typical day. We're getting ready for our science station. You can see, for those who have sailed on the Kramer before, you'll be familiar with this sail orientation. The ship is just going hove to right now. We did our science station, and now we're getting underway to deploy our Newston net. This is the net that we tow at the sea surface and we use to collect sargassum as it's drifting around. And there was a shout from aloft. Oh my goodness. The students were seeing sargassum, our first clump, after 2.5 weeks at sea. And from that day forward, we saw sargassum every day, and sargassum more than SEA had ever recorded before. I'm going to take a close look at some of that sargassum. So SEA has been towing these nets for over 45 years. We usually tow it twice a day at noon and midnight to get a daytime tow and a nighttime tow. And here is the Newston net going right through the middle of what's called a windrow, a line of sargassum that has lined up parallel to the wind direction. So as we sail perpendicular to the winds, we sail right through these windrows. Now we're going to take an even closer look at that Newston net. I could spend hours watching the Newston net. Sargassum drifting right into that Newston net. Now we won't do that, but just give me a few moments. We had gone 2.5 weeks without seeing any sargassum. That's what the whole cruise was focused on doing. So when we first found sargassum, we were pretty excited about it. Now, hopefully nobody's getting seasick as we're drifting around. All right, enough sargassum. All right, so what did we find? Not necessarily on that day, but over the course of that time period, we found more sargassum than SEA had ever recorded in our 45 years. We used to measure how much sargassum we got by how many grams, and you'd measure it with a spring scale, because maybe you'd get 1 or 2 clumps and you could measure it. We had to come up with a whole new scientific unit of measurement called a gabo. That's named after our assistant scientist, Gabrielle Page here. So there were nights when we had 1.5 gabos of sargassum coming up in our nets. We were seeing so much of it. So that was suggesting to us, given where we were finding sargassum in our understanding of ocean currents, the source of sargassum was not the Sargasso Sea, but actually somewhere from the south, on the equatorial Atlantic Ocean. And not only were we finding more sargassum than we had ever found before, but for someone who has spent a lifetime, or not a lifetime, but since 1994, I've been studying sargassum. And when I tell you this sargassum just looked different, you'll have to just trust me on that one. But we'll show you some pictures here in a little bit. But we were seeing a form of sargassum that we had not seen before. So we took a lot of pictures, we started doing a bunch of drawings, we made pressings of this sargassum and began comparing it with what we were familiar with. We went back into the historic literature that we had access to back in Woods Hole. And lo and behold, we have discovered a new form, which we believe in years to come, and we're working on the manuscript right now, that we'll be able to identify it as new species of sargassum. We're going to take a closer look at the sargassum. To give you a sense of, as I saw it drifting around, it just looks different to me. And we're going to take a look at sargassum floating around in the ocean, and hopefully you'll understand what I mean. Jump ahead in this video here a little bit. We're going to look at 3 different types of sargassum. The first one is presently called Sargassum natans 8, a variety of sargassum that in the historic literature had been considered very rare, and nobody really was paying attention or looking for Sargassum natans 8. But this seemed to be the species of sargassum that was burying the beaches throughout the Caribbean. And notice that it has this very open structure. You can see right through it because it's so open. The blades or the leaves are very far apart. The branching of the fronds is not very abundant. So it's often considered an open habitus, very open structure of algae. And we're going to see that this contrasts strongly with Sargassum fluitans 3. Now, this is a very common form of sargassum in the historic literature. This is the type of sargassum that you typically find in the Sargasso Sea and what we had been familiar with from decades of studying sargassum at Sea Education Association. And notice, smaller blades, more compact. You can't necessarily see all the way through the clump. And you can imagine small organisms hiding inside that clump of algae. I don't have a good video of the other species, but this is Sargassum natans 1, also very common in the Sargasso Sea. Notice how different that is to Sargassum natans 8, very open, and again, Sargassum fluitans, very three-dimensional in shape and structure. So we've gone on at SEA to do the genetic work, the morphological analysis of these different forms of sargassum. And as I mentioned, we're in the early stages of a manuscript to identify a new species. And a lot of this work is only possible through the work of sea semester students over the years. And from that cruise and in cruises that followed, several students have gone to regional conferences in the Caribbean and presented work that they have collected aboard SEA's ships. This is Corey Rinn, who was on that cruise where I showed most of that footage. And it was his drawings and his morphological analyses that he's presenting here and introducing Sargassum natans 8 to the scientific world. We had other students that were looking at the community of organisms that you find, and we're learning that the community of shrimp and fish and crabs is different on each of those different types of sargassum. So that is our quick tour around some of the world's oceans. We've seen rainbows in the Caribbean. We've seen coral reefs decline and then recover from a large El Nino event. We've gone hunting for and found in Medi, suggesting that the Mediterranean hasn't warmed too much yet and that these Medis are still forming. And then we've made some incredible discoveries in the new Sargasso Sea coming from the equatorial Atlantic Ocean. So these are just some of the experiences that I have been lucky enough to experience during my time with SEA. And on this day that we're celebrating and recognizing World Ocean Day, I want to leave you with this message because this is how I feel that I am hopeful. Right? Anytime people talk about what's going on in the world's oceans, you can always be sort of pessimistic and downtrodden. Things are just getting worse and worse and worse with climate change and pollution and overfishing. But what I wanted to do today here was share with you some of these experiences that I've had that remind me that there is still enough beauty and wonder and mystery in the sea to inspire the next group of students that will hopefully seek and strive toward a sustainable future for our oceans. So with all of that, I just want to say thanks to all of you for joining tonight. Thanks to Captain Glenn and the Gundalow Company for inviting me to celebrate World Ocean Day. And of course, I need to thank the crew and the students of Sea Semesters over the years that have been able to allow me this opportunity to have these incredible experiences that I've shared with you.
All right. Well, thank you so much, Jeff. That was really fantastic. Great sampling of different cruises, different types of research. And I do remember about you that you could be sitting down to dinner and hear a student on deck shout sargassum, and you drop your fork and run up for the net. Such a great passion for it, which I think, as you said, a lot of students come liking the idea of being on a tall ship and maybe crossing an ocean, but they fall in love with the ocean and with ocean science. And I know many have gone on to much further research. So I'd love to get some questions. You can type them in the chat box if you have questions. If you want to ask it in person, maybe turn on your video and I'll call on you. You can unmute yourself. So a quick question from Mary Glenn from my mother says, I'm confused at the idea that the Mediterranean is saltier than the Atlantic. Could you just touch on that?
Yeah, no, that is a great question. Now, the Atlantic Ocean is, as far as the world's oceans go, the saltiest ocean out there, say compared to the Pacific or the Indian Ocean or the Southern Ocean. But the reason the Atlantic is so salty is because of the water that comes out of the Mediterranean. And if you think about, right, the Mediterranean is a great place to go on vacation because it's always sunny. You always want to hang out at those beaches. Well, because of that enclosed basin of the Mediterranean Sea and those sunny conditions, right, just to the south of it is a desert. There's a tremendous amount of evaporation that occurs in the Mediterranean Sea. So the Mediterranean is actually pretty salty. And as it empties into the North Atlantic Ocean, it makes the Atlantic Ocean one of the saltiest oceans out there. But the Mediterranean is the source of most of that salt. Yeah, great question.
Thank you.
I'd like to have Nick Shanka ask a question then, if you can unmute there. The one with the kids,
Yes.
Former assistant scientist with SEA.
Yeah, so I was just curious if you're seeing these mass sargassum inundation events. Are they seeing it annually, or is it kind of a more cyclical, like El Nino pattern? We're seeing it every 3-5 years, or?
It hasn't established itself into a full pattern that we have been able to sort of decode yet. 2013 was a quiet year, right? 2011, 12, 2 years of heavy sargassum, a quiet year in 2013. 14, 15, heavy years. 2016 was light. And then 17, 18, heavy years. So right now it seems like 2 years of heavy sargassum, a quiet year, 2 years heavy sargassum, a quiet year. It was quiet last year, but it's picking up again.
Okay.
Right now, actually, they're starting to see a lot of sargassum showing up. There's a great paper in Science called the Great Atlantic Sargassum Belt. So the acronym GASB.
Okay.
It's gotten a fair bit of press. It's a science article. Some collaborators that we've worked with did primarily using remote sensing. And they offer a lot of hypotheses as to why. What are the mechanisms? So why is this the equatorial Atlantic blooming sargassum now? And we have hypotheses, but we don't have answers. A lot of folks are pointing to nutrient enrichment, but we've been sort of adding nutrients to this region for decades, not just the last decade. Climate change and warming temperatures, shifts in ocean circulation, we don't have the answers yet. A lot of hypotheses.
Right. Well, great presentation. Keep up the good work.
Thank you.
Yeah, great to see
Got
you.
some
guys.
future students heading your way.
All right, I hope so. Good to see you.
I think Christopher Gillard, would you like to ask yours? It's on the same topic.
Sure. You mentioned there were different communities of the small items and the different types of weed. Now, do they also show up when they're adults in different areas? So it's more likely that they circulate in a different way?
Yeah, Chris, that's an excellent question. Because, right, it's this drifting ecosystem. It is moving around, and we're starting to see that new form of sargassum showing up in the Sargasso Sea, the North Atlantic now. So through ocean circulation, it's moving around. And we're starting to see that shrimps and crabs, they seem to move back and forth across the sargassum. So there's a fair bit of overlap there. But looking at the community has helped us answer some really important questions, because I didn't show a close-up picture of it, but there are some organisms that aren't crawling around but live attached. They're called hydroids. They're a colonial organism related to corals, but they're attached to the sargassum. So they're not leaving and migrating and moving back and forth. And there's some species of hydroids that are common throughout the entire pattern of circulation. Equatorial, even if we collect the sample in the equatorial Atlantic, we can tell that that hydroid is there. But if we sample that same hydroid on a different clump of sargassum in the Sargasso Sea, genetically, we can tell there are population differences. It's the same species, but we can see they have been isolated enough through time that genetically they're beginning to show differences. So it's those hydroids that are allowing us to say that this sargassum must have stayed isolated long enough to lead to genetic differences in the sargassum itself, but also in the organisms that are attached to it. You don't see that genetic differentiation in shrimps and crabs that can move from clump to clump to clump. So we're trying to piece that part together, but we're really beginning to not only say that there's a new sargassum species, but this is a newly emerging Sargasso Sea, because we're getting these genetic differences in the sargassum, but also the community of organisms that are there. So this is pretty cool stuff.
Is it likely to introduce potential invasive species into existing ecosystems?
Yeah, you know, that's a good question. And right now, we're seeing in the community of organisms that are on sargassum, we're seeing population level differences, but we're not seeing completely different species. So there has been enough exchange that the communities are the same species, but showing some differences. But you really have to kind of tease them apart genetically. Some people refer to these as invasions, and I'm hesitant to say that. I don't want sargassum to get a bad rap.
Right, yeah.
Out floating around in the ocean, it's this oasis of biodiversity and abundance. Really important to the ecosystem. Seabirds feed there. Commercially important fish like tuna and mahi-mahi feed around sargassum. Sea turtle juveniles are known to hang out in sargassum accumulations. So it's an important ecosystem out in the open ocean. It's when it washes up on beaches that it causes problems. So I'm hesitant to use that term, though some people are doing so. So that's why it was actually SCA that came up with the terminology of a sargassum inundation event, to not sort of label it as an invasion.
We see them out at sea a lot. I work on ships and we see it a lot out there. So the first thing we always do is get our polarized sunglasses on and look over the side and see what's hanging out underneath.
Oh yeah, for sure. Yeah, get your fishing line in. That's a great place to get mahi-mahi. Yeah, thanks for your question, Chris.
I think Morgan has a question. Are you there, Morgan? I can just read it. Any reproductive structures on your different sargassum species, or does it all reproduce vegetatively?
Yeah, really perceptive question. The drifting sargassum, and this is how we can sort of tell it apart from benthic sargassum. So sargassum as an algae, you find it worldwide. Tropical to subtropical waters, even in temperate waters around the Cape, you can find sargassum attached to the sea floor. And sometimes that benthic sargassum rips up from the seafloor and drifts around. But benthic sargassum has reproductive structures, receptacles. So you can tell benthic sargassum apart from the drifting sargassum. Over the centuries that people have studied drifting sargassum, no one has ever found any reproductive structures on drifting sargassum. So even though you find genetic differences that would have come about just through natural processes of mutation, but not through sexual selection. So yeah, drifting sargassum, no sexual reproduction, all through vegetative growth and differentiation. Yeah, great question. So yeah, the genetic differences that we find in the forms are subtle. We're talking a handful, 10, 20 base pairs difference only. So without the sexual reproduction, you don't get huge differences in genetics over time. So it has to be through some sort of isolation and then natural mutation that occurs over long periods of time. So that's another reason why we feel like this sargassum coming from the equatorial region must have been there for a long period of time to allow these genetic changes to occur. But why is it blooming now? So it's not like this is the first time this sargassum has ever been there. We feel like it's been there for, you know, as long as sargassum has been around, but it just hasn't bloomed in these kind of crazy amounts. So understanding why it's blooming now is really the question. But yeah, that's a great question to sort of bring up that point.
Looking through the chat, Jim Chase said goodbye, but he was an SEA alum from W60 in 1981. And I think he's president of Seco Science Center here in New Hampshire now.
No, yeah, I'm familiar with the name, Yeah, pass along my regards to Jim. Yeah, thanks.
Mary Glenn, my mom, would you like to ask a question?
I think you're muted there, Mary. Yeah, Mary, I think you were muted.
Yes, okay. I've wondered, with all the washing up on the beaches, is anyone thinking of a way to use it? It looks a lot like edible seaweed, or maybe it could be, I don't know. Could it be used for anything?
I don't know, Mary, would you eat it? I certainly have, and I've gotten many SEA students over the years to eat sargassum. Right now, nobody's looking to turn sargassum into the next new cuisine, though people are looking to process it and use it as fertilizer, use it as compost, use it in dune restoration. So a lot of sort of enterprising people in the Caribbean are trying to turn it into something good when it washes up on the beaches, for sure. Once it's washed up on a beach, you know, at that point, any organisms or community that would have been associated with it would have, you know, either died off or, you know, moved away before it washed up onto the beach. So that's a good time to harvest the sargassum. But right now, still early stages because you need to get the sand off, you need to get the salt out before you can start using it in fields. I've made sargassum tea, pretty good. I've had a captain say that it has a little bit of a hint of honey taste to it. Though I prefer it with a lot of sugar and lemon, and then just about anything tastes good.
A lot of plankton on the crackers too.
Yes.
Question from Joan Biscanis. Would you like to ask that, Joan?
Yeah, well, I actually think that my question was answered. I was wondering if you had ever seen the attached sargassum on one of the areas that you visited. I thought that was going to be your find at the end, that you found the magic area where it was all being sloughed away from and going into circulation. But it sounds like that doesn't happen. So I am wondering though, what is your next exploration? What are you looking for next time you go out?
Oh, yeah, Joan, wonderful questions. Well, to your first question, when we were finding that sargassum on cruise C256, that was another one of our hypotheses. There is a type of benthic sargassum that is invasive throughout the Mediterranean and Spain and Portugal, called Sargassum muticum.
See,
Sargassum muticum.
Mm-hmm.
And it forms massive amounts. And I thought for sure, if we weren't going to find it out in the eastern Sargasso kind of drifting around, I thought it was going to be Sargassum uticum, but it didn't have any receptacles, which that species would demonstrate. And the structure of it, benthic sargassum is going to have this more linear, that there's an up and a down to it. And Sargassum natans 8, right, clearly has this three-dimensional structure that it's moving and floating around. So yeah, really, yeah, perceptive question, because that was sort of one of our secondary hypotheses, is that an invasive benthic form was going to be the culprit. But I have indeed found, snorkeling in the Caribbean, you're sure to come across a bit of benthic sargassum. It's very common. So when we're sailing, we always have to teach our students how to separate benthic sargassum from the drifting sargassum. It's one of the first things that we teach them. And then to the other question, what's next? Oh my gosh. Well, with sargassum, we're focusing a lot on that community and trying to understand, is there a different ecological value of these different types of sargassum? Sure, it looks different. Nobody really eats it. Nothing out in the ocean really eats it. The reason seabirds and fish hang out around sargassum is because of that community of shrimp and fish and crabs and things like that. So now what we're really spending a lot of time is understanding if the ecological value of these different sargassum types is going to play a role, especially as this sargassum form, the new one, is now moving into the Sargasso Sea. Is that going to increase or lower the biological value of sargassum out in the open ocean? So that's kind of where we're spending a lot of time now.
Could I ask just a sort of broader question about some advantages you see to using a sailing vessel for ocean research, and some of the challenges? Yeah,
excellent question, Matt. Some of the advantage, it's pretty, right? You guys go on the Gundalow just because it's pretty to look at. And it's quieter. You don't always have an engine going. So just, having that scene from the deck of a ship out over the horizon, and you don't have that noise of an engine going, and you just see the curve of the sail and the light hitting it. What a better backdrop to do science. What a better backdrop to be doing your work. So that's just me personally. I think from a experience for the students is, right, if you have a motor vessel, there's just not as much to do. But on a sailing vessel, there's always something you have to be doing. Not just steering the ship, but handling all of those lines and checking all the systems of the ship. There's just more work to be done, and that's just a good thing for students' experience, is to be in positions of true responsibility, to be getting their hands dirty on the lines, getting their hands dirty on the nets when they come out of the water. So putting them to work toward a noble end, trying to understand how the oceans work. So for me, that's what I enjoy. Right, I worked on a number of motorized research vessels over the years. And when we're not on science station, there's just nothing to do. You're just driving and steering. Put me on a ship so I can haul some lines. I want to do something while I'm waiting until I get to my next science station. And the students, I think, feel the same way, and they learn a lot from that work.
Great. I think Nick and Liz there have another question, maybe.
Yeah, I was taking a kind of memory tour back to the Central Pacific and some of your videos and shots of those coral reef surveys. Specifically, I think Rangaroa really hit home with all the bleaching that was there. But the second video was very encouraging, seeing that recovery. And what was that, 2 years of a difference? Was that?
It was, yeah.
And the fish bounced back. I'm just curious, is there any more of those kind of before and after kind of maybe cruises planned in the future, or kind of continuing that kind of temporal trend research at SCA?
That is the hope. And right, we're in the month of June. This would have been, that cruise track we do every 2 years now. But that cruise got canceled.
Yeah.
But we're hoping, come the fall, sea semester will be sailing with students again. And by hopefully this time next year, we'll be sailing in those waters and able to check out those reefs. Now, in 2018, that cruise S280, we saw reefs recovering, but they didn't recover fully.
Right.
And those El Nino events, you were asking that question about sargassum, or what is the cycle? What we're finding with El Nino events, that used to be like an 8 to 10 year cycle, El Nino to La Nina to the neutral conditions between. We're seeing El Nino cycle every 2, 3, 4 years now. So it's harder and harder for the reefs to recover in time. So hopefully we make some other bigger changes for the long-term hope. But reefs are resilient, particularly these reefs that operate, these Central Pacific reefs that live around the equatorial zone. They evolved in these El Nino, La Nina conditions. They're used to these fluctuating conditions. It'll just be a question if these cycles start repeating too quickly, which is something that they would not have evolved under those kind of conditions. So we'll have to see through time.
I think we have maybe one more question from Cindy Reed. If you're there, you can unmute.
Hi there. Yeah, I had two, if you don't mind. One was, do you have any sort of sense of whether or not the Great Barrier Reef will also recover?
Yeah, right. Pacific reefs, areas that, right, Great Barrier Reef, Australia, it shows up in the news all the time with El Nino events. So those are reefs, that's a region that is used to these fluctuating warming conditions and then cooling conditions with that cycle. So, right, the hope is that they've evolved under these conditions, that they're resilient, that they know these warm temperatures have come in the past and that these reefs have recovered then as those cool waters returned during La Nina conditions. And it really is a question, are they able to respond quickly enough, recover fast enough during those El Nino events? Because now not only do we have the El Nino La Nina cycle, but now those cycles are happening on top of increasing climate change. So everything is just a little bit warmer. So even when it cycles back to cool waters, La Nina conditions, it doesn't get as cool. And when it gets warm in El Nino, it's warmer than it ever used to be. If it was just El Nino and La Nina, sure, yeah, they evolved under those situations. Those reefs are going to recover just fine. It's that slowly incrementing change that may be hard for reefs to recover. Now, I don't want to leave you on that sort of sour note, but there are a number of scientists that are really focusing on this question, of course. A lot of people are interested in making sure that reefs are going to persist. And what they're finding are something that they call super reefs or super corals. Corals that not only live in the equatorial waters, used to these fluctuating warm temperatures, but live in the lagoon, the inner lagoons of these coral atolls that get even the highest temperatures. And they're finding that some of these species of corals are able to really withstand extreme temperatures. And they're trying to be understanding the genetics of those particular corals that survive really warm temperatures. And they're beginning to grow those corals in the lab and to see if they can start working with those corals and then replant those corals outside of the lagoons in the outer reefs as a fail-safe. So now humans coming in to try to solve this problem. It's a huge expense, but there's a sign that there are some species of corals that are adapted to these extreme warm temperatures. Or corals are going to find themselves deeper down in the water column, perhaps trying to live at lower light levels. Are they going to be able to adapt to those conditions quickly enough? So there's hope for sure, but some bigger changes I think need to come our way to help the corals out.
Cindy, did you have something else?
I did. Totally, I guess everybody forgot the first part about the whales. I was really curious whether the whales in the Pacific sing a different song and get their own song in the new year. And if there are other migratory paths that they take, other whales, you know, like widely separated. How do you say who gets what song? Who belongs to that group?
Sure. Yeah. Humpback whale songs in different oceans are different songs. So those populations don't intermingle enough for songs and notes of songs to sort of transfer ocean basins, at least as far as I'm aware. And that isn't my specialty. I'd say my specialty would be sargassum rather than humpback whales. So I might be behind in the literature on that, but my understanding is different songs for humpback whales in different oceans. And it's even that one of the things that we're doing with NOAA down in the Caribbean is that we think that there may be population level differences, that the different notes that sort of come together and create the song for the year in the Atlantic Basin, different notes come from different populations. So there's a group of whales that really kind of hangs out around the Dominican Republic. But there's another group of humpback whales that hangs out around the Lesser Antilles Islands, but yet they seem to come together and come up to Stellwagen Bank. And then there's another group of Atlantic humpback whales that go up more between the Canary Islands and Iceland. And they have a different song too. So there are regional differences even within the Atlantic Ocean, but within a basin, there's a greater sharing of notes amongst the song.
That's great. Thank you.
All right, well, we should probably end it there, but thank you so much, Jeff. Really great presentation, touching on a lot of different things, and hopefully inspiring us a little bit with that love of the oceans. So I do hope if you're ever up our way, you can come out with us on the Gundalow, and we'll tow our little plankton net there and see what we catch.
Oh, I didn't know. That's awesome. I look forward to it.
Sure. And of course we have lobsters and other such things to look at. But yeah, I'll just, if everybody wants to unmute themselves and say thank you or a round of applause, we can do that. We can say goodbye.
Thank you.
Thank you, everybody. Great to see you all.
Bye-bye.
Thanks, Jeff.
Good work, Jeff.
Thank you.
Great to see everybody.
Thank you very